I'm Jason. Today we are going to be testing to determine whether there is a relationship between the net force of an object, the mass of an object, and the acceleration of an object. And our hypothesis for this experiment is: if acceleration is inversely proportional to the mass, then the acceleration of the cart will increase as the mass of the cart decreases. Now that we've delved into our hypothesis, let's take a look at the procedure. For our procedure, we're going to want to place the cart on the track, attach one side of the string to the cart, and also put the string through the clamp pulley, attaching the other side of the string to the weight. We're going to want to establish starting and ending points for our cart that correspond to the weight when it's at the height of the table and also right when it's about to hit the floor. Next, we're going to want to measure the time that it takes from the empty cart to go from the starting point to the ending point. And then we want to put weights in the cart and also measure the time that takes for different weights in the cart for the cart to get from that starting point to the ending point. Now let me introduce you to my slightly taller friend, Abir.
Thanks, Jason. Well, here's some leftover footage from the experiments we ran. And here's the results that we got from our data.
For a mass on the cart of 0 grams, the time of trial 1 in order to hit the endpoint was 0.57 seconds, and trial 2 was 0.60 seconds. At 50 grams, trial 1 was 0.68 seconds, trial 2 was 0.75 seconds, and so forth.
And now it's time for the analysis.
We used our data through the seconds that we timed, and we plugged it into the first kinematics equation, x equals x naught plus v naught t plus half at squared, to gather our acceleration. Next, we compiled our data and calculated results into a graph. We placed mass, our independent variable, on the x-axis, and acceleration, our dependent variable, on the y-axis. We observed that they have an inverse relationship with one another.
In conclusion, our group was able to prove that mass is inversely proportional to acceleration with a constant force, net force that is, supporting our hypothesis. And as for the challenges, our group ran into quite a few hiccups along its path, including not being able to pinpoint the time as the car crossed the endpoint. This led to a significant discrepancy in our graph. Another challenge we had to face was controlling as many variables as we could during the length of the experiment. Now, in terms of whether we can prove or deny our hypothesis using the data, although there was a small discrepancy, we credit that to us not being able to pinpoint the exact time that the cart crossed the destination point. Therefore, as a general rule of thumb, our data does support our hypothesis.